Tesla's new robot can now button a shirt perfectly by itself. That might sound simple, but it is actually a massive engineering breakthrough. No other humanoid robot in the world has managed to do this yet. But here is what nobody talks about regarding this robot's real potential. Most people get the timeline completely wrong because they focus on walking. Walking is easy compared to what this new hand technology actually achieves. The real story starts with a single surprising fact about human biology. Your hand has 27 degrees of freedom to move and grip objects. Tesla's Gen 3 hand now reaches 22 degrees of that natural range. That means it can fold laundry and fasten tiny buttons without any help. Write this down because this changes everything we know about robots today. Now imagine a robot that costs less than a brand new electric car. Tesla aims to sell this machine for just $20,000 to $30,000. That price puts it within reach for millions of families around the world. But how did we get from a clumsy showpiece to this surprisingly capable worker? Let us go back to the very first version shown in late 2021. The original Optimus walked slowly, and its fingers looked stiff and awkward. It weighed around 73 kilograms, and its battery drained quite fast. Kneeling down or dancing smoothly was almost impossible for that early model. People called it a showpiece because it needed human help for everything. That first robot could not hold an egg without crushing it completely. Then came Gen 2 in December 2023 with some real improvements. Tesla reduced the weight by roughly 10 to 16 kilograms overall. Walking speed increased by about 30%, which made it look agile. The hands gained 11 degrees of freedom and could now make an omelet. It could dance and do yoga and lift battery cells inside the factory. But it still struggled with tiny objects like screws and needles and cloth. Human assistance was still necessary for complex or unpredictable tasks inside. So people said it was better, but still far from a home companion. Now, Gen 3 has arrived in 2026, and the leap is enormous. Stay with me because this next part is the most important upgrade revealed. The hands now have 22 degrees of freedom, which is double the previous. Each hand contains 25 actuators, which is 4.5 times more. Tesla added a tendon system inside the fingers to mimic human muscles precisely. This tendon design makes the hands lighter while improving grip and precision dramatically. It can now pick up a single screw and place it exactly where needed. The entire body has become lighter and the battery lasts much longer now. Walking speed reaches 8 kilometers per hour, which matches a human pace comfortably. The robot can climb stairs and walk through crowds without bumping into anyone. Its shoulders and elbows and knees bend smoothly like a real person's joints. The AI system has become smarter using lessons from Tesla's self-driving technology. This next part is the most important, because it changes how robots learn. The new AI-5 chip lets the robot understand its environment rather than follow commands. It does not need separate programming for every single small task anymore. If you ask it to put clothes into the washing machine, it understands the steps. It can pick up the clothes and open the door and place them inside carefully. If something goes wrong during the task, it tries to correct the mistake independently. Most people get this completely wrong when they compare it to factory robots. Traditional factory robots just repeat the same motion again and again forever. This Tesla robot adapts to new situations and makes decisions on its own. Now let us talk about Elon Musk's massive goal of 1 million robots annually. That number is not a fantasy, but a serious production target for the company. Tesla plans to start mass production by the end of 2026 or early 27. The Fremont factory will build the first production line for these humanoid machines. Eventually, Texas will expand capacity to 10 million robots per year eventually. Write this down, because this production ramp could be the fastest in history. The company will start with a few thousand units and gradually increase output. By 2030, Tesla aims to reach that 1 million per year milestone. But why does the world actually need 1 million humanoid robots right now? Here is what nobody talks about regarding the global labor shortage problem. Many countries lack workers for repetitive jobs and dangerous industrial environments. Elderly care faces a massive staffing crisis across developed nations worldwide. Everyday household chores like cleaning and laundry consume hours of valuable time. Robots could handle these tasks and let humans focus on creative work instead. Musk believes this technology could increase productivity and reduce costs significantly. Robots could also enter mines and chemical plants where humans face serious risks. Disaster areas after earthquakes or floods could benefit from robot first responders. But the price tag remains a big question for ordinary families right now. Early models will cost more, but mass production will drive the price down. Tesla aims to keep the final price between $20,000 and $30,000. That is roughly the cost of a good car, but for a multi-purpose robot. The entire project requires billions in investment for factories and engineering teams. New suppliers and parts manufacturing plants will need to be established globally. Even with all that investment, Musk believes robotics will become Tesla's biggest business. Now let us imagine what this robot can actually do inside a typical home. Picture waking up and finding your tea or coffee already prepared for you. The robot can make breakfast and clean the kitchen and wash all the dishes. It can mop the floor and put clothes into the washing machine automatically. After drying, it can fold everything and place them neatly in your wardrobe. It can pack lunch boxes for kids and prepare their school bags properly. When you leave for work, the robot continues taking care of the entire house. You return in the evening to a clean home with dinner already cooked nicely. Your pet has been fed on time, and the garden has been watered perfectly. For elderly family members, it reminds them to take their medicine on schedule. It brings them water and offers physical support when they need to stand. In an emergency, it notifies family members or calls a doctor immediately. For people living alone, it tracks medication schedules and doctor appointments reliably. Now think about factories and offices where repetitive tasks drain human energy. The robot can lift heavy objects and move parts along assembly lines efficiently. It handles packing and performs quality checks continuously without getting tired. Tesla is already testing these capabilities inside its own manufacturing facilities actively. If robots make fewer mistakes and work longer hours, production increases substantially. In offices, it organizes files and delivers items and helps with cleaning duties. Taking care of elderly patients is considered one of its most important roles. It helps someone stand up or sit down and walks alongside them safely. Whether at home or in a hospital, it assists with numerous daily activities. In the future, it might measure blood pressure or check body temperature easily. If an emergency happens at night, it alerts the medical team without delay. Now consider places that are extremely dangerous for any human to enter. Fire scenes and earthquake rescue zones are perfect candidates for robot deployment. Mining operations and chemical plants with toxic fumes become much safer alternatives. Cleaning high-rise building windows or repairing infrastructure at great heights works well. Military supply delivery and deep-sea exploration are other possible applications. The robot can bring groceries from the store and perform basic car maintenance. It waters the garden and mows the lawn and helps children with studies. It welcomes guests at parties and assists with serving food during gatherings. With Gen 3's improved hands and AI, these tasks become accurately executable. Earlier robots could only handle limited jobs, but now the range expands widely. Development is moving quickly toward teaching robots many different kinds of tasks. Now let us address the biggest concern that everyone asks about jobs. Will these robots replace human workers across factories and warehouses and offices? In some cases, yes, because repetitive tasks are easier for machines to handle. Factory assembly work and warehouse sorting and cleaning jobs could be automated. Some driving-related jobs and certain nursing duties might also shift significantly. But new opportunities will emerge for people who build and repair robots. Software developers and AI trainers and maintenance engineers will see growing demand. Musk says that as robots handle routine work, humans can focus on creativity. So work may not disappear completely, but it will certainly change its form. Now consider the benefits if robots handle many everyday tasks for families. People could save hours each day and spend more time with loved ones. Education and hobbies and rest could replace cleaning and laundry and dishwashing. Industries could increase production, and products might become more affordable overall. Dangerous jobs become safer when robots take over high-risk physical tasks. Doctors and scientists could focus on deep thinking instead of routine logistics. However, there are serious challenges that nobody should ignore or underestimate. The biggest challenge is employment and retraining workers for entirely new roles. If governments do not help people learn new skills, job problems will arise. Security is another major issue because internet-connected robots face hacking risks. Ethical questions remain about responsibility when a robot makes a serious mistake. Who will be held accountable if the robot damages property or hurts someone? These questions are still being debated by policymakers and experts around the world. Cost and maintenance will also be difficult during the early years of adoption. Only large companies or wealthy families may afford the first-generation robots. Electricity consumption and regular servicing and spare parts add ongoing expenses. Providing maintenance in small towns or villages could be especially challenging. Now let us look 10 to 15 years into a possible robotic future. Imagine waking up and the robot has already planned your entire day ahead. It makes breakfast and packs your bag and reminds you of your meetings. While you work, it cleans the house and does all the grocery shopping. When you return home, dinner is ready and everything is perfectly organized. This scenario sounds like science fiction, but Tesla is actively building toward it. But we must also look at the other side honestly and without any bias. Gen 3 has received major improvements, but it still has clear limitations today. It cannot safely lift a small child or handle extremely delicate medical procedures. Extreme weather conditions like heavy rain or dust might affect its sensors. Working continuously for very long hours without any rest could cause overheating. No matter how advanced AI becomes, every real-world situation is uniquely unpredictable. The robot might still need human assistance in completely unfamiliar or chaotic environments. Tesla says it is investing heavily in security, but no system is risk-free. If the software develops a bug or faces a cyber attack, problems could escalate. Imagine a robot behaving incorrectly inside a home or factory unexpectedly. The consequences could be serious, especially around children and heavy machinery. Even a small mistake in a sensitive location could become a major accident. So, safety protocols must be rigorous and continuously updated throughout the robot's life. The early versions might cost roughly the equivalent of 20 to 30 lakh rupees. That means not every family will be able to afford one immediately. Only large corporations or high-income households are likely to purchase first-generation units. Servicing costs and spare parts and electricity will add to the overall expense. Providing these services in rural or remote areas could be quite difficult. Now let us talk about the technology limitations that still remain unresolved. Gen 3 is definitely much better, but it is not perfect by any means. In some difficult situations, it may still need human guidance and supervision. For example, performing very delicate tasks or handling unexpected emotional scenarios. Conditions like extreme temperatures or water exposure could degrade its performance significantly. No matter how well we train AI, every real-world situation presents unique challenges. Next come the ethical questions that society must address before widespread adoption. If robots start handling many jobs, what happens to displaced human workers? Will they receive new training, or will new job roles be created for them? Could human care and emotional connections suffer if robots care for the elderly? Robots cannot provide genuine empathy or emotional warmth that humans need. If robots continue becoming smarter, we need new laws to govern their actions. Who is legally responsible when a robot makes a decision that causes harm? These questions are still being discussed, and no one has clear answers yet. If we look at the overall picture in a balanced and realistic way, Elon Musk's goal is certainly ambitious and inspiring for the entire tech industry. But building 1 million robots and using them safely is not easy. Preparing society for such a massive change will require careful planning and education. Gen 3 can certainly be called a major technological achievement for Tesla, but it should not be seen as a magical solution to all problems. Its real success depends on how responsibly and wisely it is adopted. The transition must be gradual and inclusive to benefit everyone fairly. Now let us revisit the hand dexterity, because that is the true game changer. That 22-degree freedom and tendon system mimic human biology astonishingly well. This allows the robot to perform tasks that were impossible just 2 years ago. Folding clothes and fastening buttons are incredibly complex for any machine to learn. The AI-5 chip processes visual and tactile data simultaneously for precise control. If the robot feels an object slipping, it tightens its grip automatically. If it detects an obstacle ahead, it changes its path without any command. If a person is nearby, it maintains a safe distance while moving smoothly. Cameras and touch sensors and force sensors work together in perfect harmony. This sensor fusion makes the robot aware of its surroundings at all times. Earlier models could not handle delicate glass objects without breaking them completely. Now it can pick up a wine glass and place it down gently. It can hold a pen and write or draw basic shapes on paper. It can handle screws and nuts and bolts on an assembly line accurately. The walking gait has also improved to look natural and fluid like humans. The robot no longer shuffles or wobbles when changing direction suddenly. Its balance system uses advanced gyroscopes and accelerometers for real-time adjustments. If you push it gently, it recovers its balance without falling over. This stability is crucial for working alongside humans in crowded factory floors. The battery technology borrowed from Tesla's electric vehicles provides extended operation time. It can work for several hours on a single charge without needing a break. Energy efficiency has improved because motors and actuators consume less power now. This means lower electricity costs and longer intervals between recharges. The production plan is equally ambitious and deserves our close attention. Tesla will start with a small pilot line at the Fremont factory. They will build a few thousand robots initially to test the assembly process. Then they will scale up gradually to avoid quality control issues. By 2027, they hope to reach tens of thousands per month. The Texas factory will eventually handle the bulk of 1 million production. Musk has compared this ramp to the Model 3 production acceleration. He believes lessons from car manufacturing will directly apply to robot assembly. The supply chain for actuators and sensors must be built from scratch. Tesla is already partnering with multiple suppliers to secure component availability. The entire ecosystem will take years to mature fully and stabilize. Now think about the long-term vision beyond just factory and home use. Space exploration could benefit from robots that work in zero-gravity environments. Underwater inspection and repair tasks could be performed without risking human divers. Agricultural tasks like harvesting fruits and vegetables could become fully automated. Construction sites could use robots for heavy lifting and precise measurements. Logistics centers could run entirely with robot workers handling packages all day. The possibilities are vast, but each domain requires specific training and adaptation. The AI system needs to learn each new environment through extensive data collection. Tesla plans to use its fleet of robots to share learning experiences globally. This collective learning approach could accelerate capability improvements dramatically. Every robot in the field sends back data to improve the entire system. That means each robot becomes smarter as the overall network grows larger. This is the same strategy Tesla uses with its self-driving car fleet. The network effect could give Tesla a massive advantage over competitors. Other robotics companies do not have millions of units collecting real-world data. This data advantage might be the most underestimated factor in the competition. Now let us briefly address the competitors who are also building humanoid robots. Boston Dynamics has impressive robots, but they are extremely expensive currently. Figure AI and others are racing to catch up with Tesla's progress. But none of them have Tesla's manufacturing scale or AI data resources. Tesla's vertical integration from batteries to AI chips is a huge edge. They control the entire supply chain and software stack completely in-house. That allows faster iteration and cost reduction that others cannot match easily. However, Tesla still needs to prove reliability over millions of operational hours. The robot must work consistently without breakdowns in diverse real-world conditions. Durability testing is ongoing, and early results seem promising so far. Only time will tell if the million-unit goal becomes a reality. But the trajectory is clear, and the improvements are genuinely remarkable. We are witnessing the early stages of a robotic revolution unfolding before us. The next 5 years will determine whether this technology enters every household. Stay curious and keep watching because this story is far from over. The final chapter depends on how we as society choose to embrace it. For now, Tesla has delivered a machine that surpasses all previous expectations. And that alone is worth paying attention to in the coming years.